Hello friends, welcome to this video. Today we have our Delta Drive VFD control panel for pressure booster system. Actually we have two control panel. One is 5 HP, 3 pump with 1 VFD, and another one we have 3 HP, 2 pump with 2 VFD. So in this video I will guide you how to do the settings, how to do the wirings, and what are the benefits of using VFD control panel instead of a fixed speed system. What are the pros and cons, what are the features included in this panel, what are the protections it offers to the pump. So in this video you will be completely guiding for the entire pressure booster system and which control panel you have to select for your pressure booster systems. So let's get started. First of all, we will talk about the application and use. These kind of control panels are used in pressure booster system which are installed in a multi-story apartment, either in a hotels, to maintain the constant water pressure in the pipeline, either to fill up overhead tank for the domestic water. These control panels are having a variable frequency drive inbuilt, so it can adjust the speed of the motor according to the requirement of water pressure. If your water demand is too high, it can operate the pump at high speed. If your demand is low, then this panel can operate the pump at a very low speed. So as per the demand of the water, it can adjust the speed of the motor and provide constant water pressure in a pipeline. So these are very much suitable for the hotels. Like in the morning, there will be a high demand, and at the noon time and at the midnight time there will be a very less demand in a hotel. So it can adjust the water pressure according to the demand. So you can observe 30 to 40% energy saving in the system, as well as the pump life will be enhanced because there will be a not fixed start and shut down. It gives the smooth start and smooth stop to the pump. So pump life also enhance. You will never face any jerk in a pipeline, never face any jerk on a motor and in a shower panel. So these are the advantages of using the VFD panel. First one, you will not face any jerk in a pipeline, any jerk in a water, or any jerk in a motor. Second benefit is energy saving. As these drives and entire control panel manage the speed of the motor according to the requirement, so your pump operates at a different speed at different particular time. So it offers 30 to 40% energy saving, as well as these control panels offer maximum protection to the pump. Your pump keeps entire time very much safe because these drives has inbuilt protection of overloading, dry running, as well as higher voltage, lower voltage, phase failure, reverse phase. All kind of protection which are required to operate the pump are inbuilt in the drive. As well as this control panel has 4-inch graphic display, and we have provided indicators, RYB input indicators, and indicators for each pump which are in operation, as well as there is one indication for water low. If your sump water level is down, it will sense the water level and it will shut down the pump. If your sump water level goes high, then only the pump will be running. We have provided bypass system in this panel. So here is auto manual switch. In case of emergency, like there will be a failure in VFD, either PLC, either HMI, in that case, you can operate the pump in a fixed speed system. We have provided contactors in the panel. So through the pressure switch, it will sense the pressure and your pump will run on a fixed speed. So for emergency, you will never face out of the water. Hotel industry is very critical application. You cannot shut down the water for any particular time. So this bypass system is very useful when the system is under maintenance or under failure. And the entire panel is made out of the reputed OEM parts. Like we have used Schneider make switch gears, INVT make HMI. Inside, if you check, there we have used Delta make VFD and Delta make PLC, and Elmex make connector we have used. So entire system is built out of a reputed OEM parts. So there is very less chance of failure. Installation of this panel is very easy. Actually, it is a plug and play solution. You don't need to do any setting in a VFD, any setting in PLC or HMI. You just need to set the required pressure in HMI, do the wiring of mains. You have to give the mains input supply, pump connection you have to do, and pressure transmitter you have to connect in a pipeline and give the connection to the panel. That's all. The entire system will run automatically and maintain the constant pressure in a pipeline. So this is predefined, pre-designed for pressure booster application. So you don't need to do multiple type of settings in this control panel. It is actually a plug and play solution. Any customer, any dealer, any pump operator, either end customer can easily install this panel and commission it very easily. So now I will guide you how to do the settings in HMI, how to do the wiring in control panel, and I will thoroughly guide you for the control panel. So first of all, this is 3 pump panel, 5 HP, 3 pump with 1 VFD, and this is 3 HP, 2 pump with 2 VFD. I will show you internal of the panel also. You can check here, this is single drive and 3 pump, and this is 2 pump with 2 individual drive. Here we have taken 2 pump to operate and give you the demo. One float switch we have used, sump tank float switch, and one source we have used to give the signal to the control panel for pressure transmitter, because actual pressure transmitter we cannot connect here. It requires a water line. So we will give source input to the control panel to observe how the pump operates. So first, let me guide you through the material of construction. Here we have provided RYB input indicators, 4-inch touchscreen HMI. Here is indicator for water low. If your sump tank water is low, this indication will blow and you can identify there is no water. This is SPP not okay indication. We have provided inbuilt SPP. So if there is one phase missing, it will immediately trip the pump. These are indicators for pump running status. This is auto manual switch for each individual pump. This is auto manual switch for entire system. Okay. The same way you can identify over here RYB indicators lamp display, and this is 2 pump panel. So 2 indicator for each pump, 2 selector switch for each pump for auto and manual mode, and this is input mains MCB. Okay. Let's get inside. Inside you can check, here is mains input MCB, this is INVT display. Here you can check, we have provided individual MCB for each pump, and here you can check, we have provided SPP for single facing prevention. These are individual contactors for each pump. As this is 3 pump system, these 3 contactors are for bypass, and these 3 contactors are for auto mode. That will run through VFD, and these contactors will run the pump directly online. This is PLC, Delta Make PLC we are using. This is SMPS, and here you can see isolation transformer is also provided to generate neutral. So in this panel, no neutral required. Here you can see Delta Make VFD we are using. and let me guide you through the connections. Here you have to give mains input supply RYB. These three are pump output, pump 1, pump 2 and pump 3. Here you can connect some tank float switch. First two terminal you can connect float switch for some tank. Here we have given the connection diagram. So first two is float switch connection. Next two is master pressure switch, common pressure switch for all three pump. Then this is pressure switch 1 connection, pressure switch 2 and pressure switch 3 connection. We have given one master input for pressure switch and individual pressure switch also you can connect. So you can operate all three pump by using single pressure switch. Either you can operate all three pump by individual pressure switch also. Both option is available over here. Last two connections are for pressure transmitter. Plus 24 you have to connect in plus point of pressure transmitter, and IB1 you have to connect in minus of pressure transmitter. So last 2 points are for pressure transmitter. So these are the wiring points, and this is only you have to done at the time of installation. Okay. Now this is 2 pump with 2 VFD. Here you can check delta make VFD provided. Neutral transformer is also given. Here is also connection is same. Mains input connection, pump 1 connection, pump 2 connection, one connection for bottom tank float switch, then master pressure switch connection, individual pressure switch connection for pump 1 and pump 2, and last 2 points are for pressure transmitter connection. Plus 24 you have to connect in a plus point of pressure transmitter. IB1 you have to connect in a minus point of pressure transmitter. So that's all. Connection is very simple. Now I will guide you how this system operates. So here we have taken 2 pumps and both pump connected in this panel. I am keeping this system in auto mode. Right now you can see set pressure is 3 bar and actual pressure is 4.27 bar. I am reducing this pressure through the source. Now you can see pump 2 turn on through the VFD, and after some time if your pressure is not achieving, first pump will also on in a fixed speed system. Now you can see first one is also turn on a fixed speed through contractor. Now I am increasing the pressure. So you can see the frequency of pump 2 has been reduced. Now you can see pump 1 is also turned off. As this actual pressure continuously above the set pressure, so only pump 2 is on through VFD. You can see the speed is very low, and after few seconds this pump will also turn off. Now you can see it goes in a sleep mode. Now I will show you the cascading. In this operation, pump 2 was on through the VFD, and now again I am reducing the pressure. You can see pressure reduced. Now pump 1 turn on through the VFD, and pump 2 will on by contactor at a fixed speed. So this is how the cascading works. It alternates the pump in every cycle, so both pump will get equal load throughout the lifespan. Now both pump are turned off. Now I will show you how pump operates through VFD and through fixed speed. So now you have to observe, I am reducing the pressure. You can see I am reducing the pressure. You have to notice how pump operate in VFD and fixed speed. You can see when pump on through VFD, it slowly start and reach the full speed. You can see pump 2 on through VFD, and you can see over here. Now this pump will run on a fixed speed. It will give a jerk and start immediately. You can see it start at a full speed. So here you can identify when pump run through VFD, it starts smoothly and stops smoothly. When pump run at a fixed speed, it directly on a full speed and shut down immediately. This will give the jerk in a water pipeline, and as well as wear and tear you can see in a motor. And this pump, when on and off through VFD, it will not give jerk, water jerk in a pipeline, and no jerk on a pump as well. So basically VFD enhance the life of the motor and your system as well. Till now we have operated this system in auto mode. Now I will show you how manual mode is working. If you face any failure, you can keep the entire system in manual mode. You can keep that pump also in manual mode. So when you put this system in manual mode, pump directly on off through the pressure switch. Here we have connected two pressure switch. You can see pressure switch 1 and pressure switch 2. So right now pressure is low, so this pump is working. Now I am keeping this pump high. You can see one pump off, and pressure switch 2 again I am keeping in a high. Both pump turn off. I show you again. When I keep pressure switch low, pump turn on. Again second pressure switch also I keep low, pump turn on. Pressure high, pump off, pump off. This is working in manual mode. I can say it as bypass mode. In the bypass mode, HMI, PLC or drive is not in function. Pump on off through these contactors. Pump on off through this bypass contactor. I show you again. And through this pressure switch, you can see these contactors are getting on off, and pump directly getting on off through the contactor, bypassing the entire electronics, drive, PLC, HMI, everything. So this is the bypass mode for emergency use in case of failure of any component. Okay, so you will never face out of the water in hotel type critical applications. Now we have connected this pump to two pump control panel. Here, as you know, both pump has individual VFD. Now you can see the set pressure is 3 bar, actual pressure is 5 bar. I am reducing the pressure. Now you have to see the pump operation. Now first pump started smoothly through the drive. Pump 1 is on. After few seconds, another pump turn on smoothly. So you can observe both pump now running on a VFD and slowly increasing the RPM and reach the full RPM. Okay, so in this case, when there is individual VFD of all pump, system runs very smoothly, no wear tear on pump and no jerks in a water pipeline, either in a shower. Okay, so when you require a smooth operation, you can select individual or multi-VFD panel. Now RPM adjustment also I show you. Set pressure is 3 bar, current pressure is 2.2. Now I am increasing the pressure. You will observe RPM will be decreased. Now 3 bar pressure reach, RPM decreasing slowly. You can also see over here both pumps slow down. One pump shut down, one pump is maintaining the pressure, running at a low speed, 1800 RPM. Again, at the same time, I am reducing the pressure. Now again it is increasing the speed. It is working on a full speed right now. Okay. As you can see, pressure is not achieving. Another pump also turn on. Okay, so this is how the system operates. So this is multi-VFD panel and this is single VFD panel. Now major people get confused when you have to use multi-VFD panel and when you have to use single VFD panel. When you are operating the pump to fill the overhead tank, then you can use single VFD panel. So if there is a jerk in a water pipeline, it will not directly visible to the shower or in any tap. But when you are connecting your pump output directly to the showers and water taps like in hotel, then you have to use multi VFD panel, because all pump will turn on and turn off through VFD very smoothly. So in that case, you will not face any jerk in water, any jerk on a pump. So this will give you more energy saving, smooth operation. This will be budget friendly and can be used to fill up overhead tank. This panel can be also used in inline system where your water pump output is directly connected to water taps, but sometime you will face up down in a water pressure. So this is the basic difference between two control panels. Here only one pump will operate through VFD and rest of two pump will start and stop directly through the contactor at full speed. Here both pump have individual VFD, so each pump will turn on and turn off through the VFD. So both pump will have smoother operation. Here only one pump will have smoother operation. Rest two pump will directly on and off through contactor on a fixed speed. So these 2 points you have to consider while selecting the control panel for your application. Now I will guide you through the settings. Here you can see is a date and this is the real time, and this shows the set pressure and this shows actual pressure in a pipeline. If you press a main menu, at the time of installation you have to do only one setting, that is a required pressure, set pressure. So whatever pressure you want to keep in a line, you can set over here. Like if you want 4 bar, you can enter as 4. So 4 bar will be set pressure. This is slip RPM. Here we have default 2500 RPM. When a pump reach 2500 RPM, then after shut-off cycle starts. This is slip time. After maintaining 2500 RPM for 30 seconds, after that the shut-off cycle will start. Wake up difference. This is 4 bar set pressure. Wake up difference is 1 bar. So 3 bar will be cut-in pressure and 4 bar will be cut-off pressure. So this is the difference of pressure. You can say set 0.5 bar as well and enter. So 3.5 bar will be cut-in pressure and 4 bar will be cut-off pressure. Wake up time by default we set as 1 second. So after crossing the 3.5 bar, once the pressure reaches below 3.5 bar, it will wait for 1 second and then after your pump will start. So this is wake up time. You can set in second as per your requirement. You can set 5 seconds as well. So when your cutting pressure, when your actual pressure will go below the cut-in pressure, after 5 seconds the pump will be start. So at the time of installation only you have to set pressure and wake up difference. So that will be your cutting pressure and cutoff pressure. That only you have to do at the time of installation. Rest of all settings are detailed setting that will be used for a particular application or particular requirement.